Hello. So what we're doing today is we are getting ready a tray for analyzing carbonates. So we're gonna analyze the C13 and delta weighting of carbonates. In the samples we want to analyze, there are ostracods, which are tiny little animals, in that case from the Chesapeake Sea, and their shell is made of carbonates, and they're really useful for paleo studies. So I have about 50 of them to analyze. So I'm gonna get ready a tray for 50 samples. So the first thing to do is to measure to weigh out standards, because when we do stable isotope studies, well, everything is measured against the values returned by given standards. So we're gonna get ready a tray with 3 standards actually, regularly placed on that tray. And these standards in that case will be NBS 19, NBS 18, and a home standard is called TASOS, which this TASOS is used in that case just to see how the quality of the measurements, just to see if it's stable, just to see if we obtain the values that are expected. So the customer told me that in every vial they sent me, there was about 90 micrograms of ostracod shells. So it's roughly, and there might be some impurities, but according to what they told me, it's not significant. So we say there's 90 micrograms of carbonates. So the idea here is to measure the exact same weight for all the standards. That is, every vial I'm gonna place here, I'm gonna weigh 90 micrograms of NBS 19, 90 micrograms of NBS 18, and 90 micrograms of TASOS. The reason why it's important is because the RMS is sensitive to the amount of material, meaning the delta value it's going to return will change based on how much material is put in a vial. So there's several ways to get around this. The first one is to weigh the exact same amount. So we try to do this as best as we could. It's however not possible. Many reasons. But the first one is the ostracods are tiny little shells. They are not ground, they just put in the vial as is, and their weight changes within a range, I don't know, of 60 to 100 micrograms, something like that. So just the weight of the samples will change. And in addition to this, weighing exactly 90 micrograms with this microscale is close to a nightmare. So we do this the best we can, and in addition to this, we're gonna correct for it. That means we're gonna try to see how it changes with the weight of the samples and correct for it. And the way we do this, we take one standard and we put several amounts of that same standard, like in several different vials. We put different amounts. Like today I'm gonna put 30, 60, 90, 120, something like that. Okay, 4 or 5 of them. We try to encompass all of the possible weight that the samples will return. And then we'll obtain the result, we'll obtain a delta value that changes with weight, and well, it's part of the data processing, but the idea is you do some kind of a regression line or something like that, just to, and you see how it changes with weight, and then you're able to correct. That's the principle. So that's how a tray for that type of measurements is made. So now how do we do this? Well, with my tray, that's the vials I'm gonna use. In that case, they're tiny vials because I have only 90 micrograms of material. For that measurement, it's better to work with 160, 180 micrograms of material. In that case, we use larger vials. These samples, the customers did not have enough materials to put in large vials. So to work with smaller amount of materials, I'm gonna use tiny vials. And the only reason why we use tiny vials is because that way the samples, the CO2, because it's CO2 we measure, after dissolution of the carbonate shells, the CO2 won't be diluted as much because the volume of the vial is less. The CO2 won't be diluted as much, so we'll have a higher signal. So that's why we use small vials. I prefer to use larger vials. It's more forgiving, but in that case, we don't really, I mean, that's the way we have to do it. It works, but it's easier and a little bit better to use, at least in my opinion, to use larger vials. So, how do we weigh for carbonates? We use, first of all, we use clean tools. I'm going to use all of these tools here. This will be to scoop the carbonate powder, and this will be to fold the piece of paper that I'm gonna use. And you'll see these are necessary because if I want to do this with my finger, it's gonna go all over the place. So first things first, we can use methanol is the best. So I have here a little squirt bottle full of methanol. Now wipe my tools. I mean, they were not dirty to start with, so should be fine. But by precaution, if you don't remember, if you don't know they were dirty, if they are clean or not, just clean them by default. And then also the little table we're gonna work on, and that. There. So now the paper. So the weighing paper is here. And what we do, there. That's the compressor. That starts with me every time and it's very annoying. So we cut little square of weighing paper. And I try to not go Well, to me that's the best size. Smaller, it becomes really difficult to manipulate, at least for me. Bigger, it will make the weight on the scale move a lot more than it should. For I don't know exactly why. Maybe it carries more statics, maybe it's more sensitive to whatever airflow is in there. But I find a little square like this, it's just fine. So the way I do it, but everybody's got his own preference. I will fold it like that in the middle, and then I sort of curl it towards the inside. And the reason I'm doing this is because if you do that, it goes into the vial. It's easier to put your samples into the vial. So, putting it on a scale here that I'm going to clean first. So there's several ways to do it. If you need a thorough cleaning, you just turn it off, unplug, take the two little parts, the two parts here, has to be unplugged. Before you do this, delicately take this and this out, wipe